let's go over the difference of perfect squares. So let's just look at some examples. X squared minus 9 is an example of the difference of perfect squares. X squared minus 16 and x squared minus 25, all examples of the difference of perfect squares. So difference is the solution to subtraction, so they'll have a subtraction sign here. Perfect squares are numbers or terms we could do the square root of. So we could do the square root of x squared, we could do the square root of 9, we could do the square root of 16, and we could do the square root of 25. That's why this is the difference of perfect squares. Two perfect squares being subtracted. Alright, so now let's take a look at how to factor this. Let's rewrite this. This is x squared plus 0x minus 9. And if you remember, when we factor, we're going to have x and x, and we have to add up to 0 and multiply to negative 9. So in order to add up to 0, the numbers have to be opposite. So we have to multiply negative 9, so the sign's going to be different, opposite. So what multiplies to negative 9 adds up to 0, positive 3, and negative 3. So let's look at this one. X squared plus 0x minus 16. So we have x and x. To add up to 0, multiply it to negative 16. That'll be a positive 4 and a negative 4. And if we go here, x squared plus 0x minus 25. X has to add up to 0, multiply to negative 25, positive 5, and negative 5. So if we look at this more generally, if we have x squared minus b squared, so it's going to be x plus b, x minus b. So here b squared would be 16, and the square root of it would be 4 and 4. Or think of it as differently. So we have x squared minus some number that's a perfect square. It's going to be x plus the square root of that number, x minus the square root of that number. So here 25, we have x plus the square root of 25, which is 5, x minus the square root of 25, which is 5. So if we had x squared minus 81, it's going to be x plus 9, x minus 9. And of course, this could be switched, x minus 9, x plus 9. It doesn't make a difference. And this rule applies to all perfect squares, all difference of perfect squares. So, for example, we could do the square root of this term, we could do the square root of this term, and it's separated by a minus sign. So the square root of 4x squared is 2x and 2x. So even the square root of this goes into both spots. And the square root of 121y to the 4th is 11y squared. So minus 11 squared plus 11 squared, 11y squared. So if we look at a previous one, x squared minus 9, we put x and x in this location. That's actually the square root of this term. The square root of x squared is x, so that goes in both spots. The square root of 9 is 3, so we have plus 3, minus 3, or minus 3 plus 3. So here the square root of 4x squared would be the square root of each one. Square root of 4 is 2, square root of x squared is x, so 2x and 2x. Square root of 121 is 11. Square root of y to the 4th is just y to the half, y to the squared. So you just have whatever this is. So square root of y to the 4th is y squared. So we end up with minus 11y squared plus 11y squared.